Okay, so this is a review of Newton's second law and some of the questions you were asked. Okay, so it's important to break down all of the maths questions. So an 80 kilogram skier, so we're given a mass, so mass is equal to 80 kilograms, has a force of 200 newtons exerted on him down the slope. Okay, so he's got a force of 200 newtons. Calculate his acceleration down the slope. So we're calculating acceleration. So I've done step number 1, write down the information. Step number 2, write down the equation. So if you look at those things we've got, clearly that relates to Newton's second law, F equals ma. So A, if I rearrange that, is equal to F divided by m, which I can then put the numbers in. So 200 divided by 80 kilograms, which is equal to 2.5 meters per second squared, because it's an acceleration. Okay. The next question, is the slope less than or more than 45 degrees? This is explain your answer. Now this is more of a mathematical trick. If we imagine we're talking about two forces, we've got the force acting downwards, which is the weight, okay, and we know that the slope, we're trying to work out the angle of the slope, and there's a force acting down the slope. So I'm just going to call this one FA, so as the force just acting down the slope, and I'm going to call this one FG just for simplicity. Now if this triangle is 45 degrees, then Pythagoras' theorem gives us the following relationship. For triangles that are 45 degrees, we've got the hypotenuse and the two other sides. So if we take those as 1, then that means the ratio of those other two sides to the hypotenuse is the square root of 2. So by doing that, we have this side here, and we have the weight, we have the force acting down the hill. We want to know if this is 45. So what we can do is we can take the weight and we can divide that by the square root of 2 in order to calculate a magnitude of this particular down the slope if it is 45 degrees. And you'll find that your answer is greater than the 200, significantly greater. It's about 500. So when you put that into your calculator, you'll realise if it's greater than 200, therefore that particular angle is far too big. Therefore, the slope must be less than 45 degrees. Okay, the next question. An ice hockey player has a sudden impact force of 200 newtons, and due to an unexpected collision with the wall, that's due to the force, and the mass of the player is 100 kilograms, so he has a mass of 100 kilograms. It says find his acceleration, so exactly the same process again. So we're going to do 2 for A is equal to F over M, which is equal to 2000 divided by 100, which is equal to 20 meters per second squared. The next question says compare this with the acceleration when he free falls. The acceleration due to free fall is 9.81 meters per second squared on Earth. So if all we have to do, the command word in this question is to compare them. So if we compare 9.81 with 20, we'll see that 20 is approximately double the value of 9.81. Coming out of the dive, a 75 kilogram astronaut in training experiences an acceleration of 40 meters per second squared. Calculate the force acting on them. So this is just using Newton's second law directly, and you will get an answer of 3000 newtons, so just m times a. Compare this with the force when he's stationary on Earth. Well, if he's stationary on Earth, then he has no acceleration, so it's just the force acting downwards on him, so that will be 750 newtons, so that's his weight. So if we compare those two numbers, again, it's not only the approximation, but it's approximately 4 times greater. Okay, why is it important that they are seated and strapped in before the dive ends? If they're not seated in, then they're obviously going to not be able to undergo the rapid deceleration required in order to reduce them to rest. So when they're being slowed down, they're going to experience significant forces, so that is to prevent injury. A 50-gram tennis ball may be accelerated at 1,000 meters per second squared to reach a speed of 130 miles per hour. Calculate the force required to accelerate the ball. So again, this is just Newton's second law. The key thing for this is not to make the mistake of grams. We have to put it in kilograms, so it should be 0.05 kilograms multiplied by 1,000 meters per second squared, which will give us an answer of 50 newtons. Is that reasonable? It's not a particularly large force, considering the human arm can lift a weight typically of about 250 newtons with one arm quite comfortably. Then that force is very reasonable. So there's nothing to suggest that that is wrong. If you get a question like that, usually you just need to look at the order of magnitude of the number and decide whether it's roughly in the right region. And the final one, when a force of 200 newtons is exerted on an asteroid, it accelerates at 0.002 meters per second squared. Find the mass of the asteroid. So this time we rearrange F equals ma again, this time to give us F over a. So we will have 200 divided by 0.002, which gives us an answer of 1.0 times 10 to the 5 kilograms. Make sure you get your units right for mass.